Welcome to video 12.8. Today we're going to be talking about residual plots. So if you'll recall from yesterday's lesson, when we used our regression equation to predict an outcome, we looked to see if it was an overestimate or an underestimate from the actual data. And what we found is actually called a residual. The residual is the actual given y value minus the predicted or found y value. So that's the difference between the predicted estimate and the actual value, basically telling you the error measure between these values. If we look at exercise 1, it says let's try to understand what this really means. To approximate the residual value from a graph, we're looking for the distance between the data point and the line that represents the residual value. Notice some are above and some are below the regression line. If the data point is below, the residual is negative. If the data point is above, then the residual is positive. Now we're going to use the given scatter plot with a regression line drawn in to estimate the residual. So we're going to actually draw in what that residual means and kind of looks like. So if I look at the first example here, it says that the curb weight in hundreds of pounds is 25.33. So that's this value right up here. The fuel efficiency, or miles per gallon, as we found in the point, is about 43. So that's the actual. How far away is that from our line of best fit here? So I can see that it is above, but we want to know about how much above is that. So I can draw in a line from that point to the line of best fit. So this purple line here represents the residual. So how far above, first of all, it's above. So how far to get from the line, which looks like it's about 40, would have been the predicted value. How far above is this? Well, if it's 43, that means that it's about 3 above. So that's where this 3.1 came from. It's just showing that it's actually 3.1, but you can see there that it looks like 3. So then if we look here at the 26.94, which is 38, so that's this value right here. We can see again that it's above, so it's going to be a positive residual, but it's also very close to this line. I could draw it in there and show that it's a small value. So now that I've drawn in this residual line here, I can see if I look over, they told us the actual is about 38, but if I look at my line of best fit, it looks like it'd be closer to, about halfway there, so 37 and a half, I'm going to say, because 37 would be right in the middle. It's a little higher than that, so I'm going to estimate that it's about 1/2 higher than the predicted value. And again, these are just kind of estimates based on what it looks like on the graph here. The next one they did for us, so we're just going to draw in the line that represents the residual. So if we look at that 27.79, which is about 30, you can see when we draw in that line, and then if we look over to see what's the distance, well, it's going from about 30 up to the line is closer to about 36. So that's about 6, which is why it's 6.1. They gave it to us, and it's negative because it's below the line. Let's try estimating the next one. I'll draw in the residual first. So I can see that it is above, and when I try to trace it over, and you kind of have to do the best that you can, to me it looks like it's more than 1. It's like down in here, so I'm going to say that it's about 1.5 above. So this value I'm going to estimate to be 1.5. And the last one, again, I'll draw in the residual first. So from the line of best fit up to the residual, to the actual plot there shows the residual, and they told us that the actual point is at 30, and it looks to me like it's maybe like 1 below that, so I'm going to estimate that this is 1. The residual is positive again because it's above, so I'm going to estimate that as 1. So in that one, we were all doing these estimates because we didn't really have the line of best fit, but we can find the true residual when more information is given. This was just an estimate to start giving us an idea of what the residual plot will look like. Then we can look at analyzing a residual plot. So the residual plots indicate if a linear model would be a good fit for the given scatter plot. If there is no pattern, it means that it's a good linear model. But if we start seeing a shape or a pattern, then that means that it's a non-linear model. We cannot tell what it is, but if there is a shape or pattern, all we know is that it is a non-linear model. We cannot say whether it's exponential or quadratic, but it'll look more like that in the residual, and we'll explore this more in class. Have a good night.